Today I want to share with you one of the most useful tools I've found for my own teaching and for my students' learning. And it's actually a foundational idea from the world of storytelling. It's what we call a 3-act structure. And once you have eyes to see it, it's actually a little bit hard to unsee. So I apologize in advance for any movies, books, and plays that you're about to enjoy in the future, because often they use this simple 3-act structure over and over again, but to great effect. Now, if you're thinking perhaps, hold on a second, you can't boil down every story in the world to just 3 simple ideas, you'd be right. The reality is actually a little more complicated and technical than that. However, the foundational concepts are actually things that get used over and over again, and I can prove that to you. If you think about the basic 3 acts of a story, they are remarkably consistent across all the different genres and types of things we like to read or watch. The first act is what we call setup. You have to be introduced to a world, to a context, and to the characters who are going to be playing the parts of the story. Otherwise, you don't care, you're not emotionally invested. But then secondly, there has to be a conflict. This is the second act. There has to be some tension, some drama, some challenge for the main characters to overcome. And then finally, the third act is what we call resolution. This is where the challenges are overcome, everything is tied up in a nice neat bow, the hero overcomes the villain, and everything comes out nicely in the end. Now, like I said, once you recognize these 3 acts, you'll see them over and over again in stories. But the point I want to convey to you today is that these 3 acts can also be used as a very helpful structure for our lessons, especially when we have some kind of real-world context, as you're exploring today, to be able to connect the things that we want to teach, like mathematics, which can often be quite abstract and not to do with any real world. So what I want to do is give you some very brief examples for how a setup, conflict resolution structure can be used to attach the idea or the concept or the skill that we want to teach to a real world concept or context that will actually be interesting to our students. So here's my first example for you, a hypothetical scenario. I'm not going to play all of this out for you. I'm just going to introduce the bare bones of the idea, but you'll be able to see hopefully how the setup, conflict and resolution pieces fit together. Use your imagination with me. Let's suppose there's some disease floating around the population, but there's also a test that exists for that disease that isn't guaranteed, it's not 100% accurate, but it is pretty close and it's very quick. You one day wake up feeling sick, you do the right thing and do a test, and bad news, you test positive. So the question for you is, what's the chance you actually have the disease? Now what I've done just now is I've provided you the setup. A simple premise, given you the ideas, but now I introduce the conflict. When I say, here are a few options, in my class I will then ask them to vote, multiple choice, maybe just using their fingers to do it very quickly. And almost always, on such a simple presentation of the question, students will come up with the answers that they think are most sensible or intuitive. And in fact, the real answer to this, the probability underneath this situation, is wildly counterintuitive. And so the answer being revealed as not what they expect, and no, I'm not going to show you right now, that's the conflict. And that gives me a reason to explain the conditional probability ideas underneath this to reach a resolution and a new understanding. Let me give you a completely different context. Let's think about astronomy. I love the planets. I think they're beautiful and amazing. And one of the most unusual things about the planets is that we discovered them mostly by looking up at the sky. We've known about them for millennia, and we've particularly noticed that amongst all of the stars, there are particular celestial objects that don't move in the normal ways that you would expect stars to do. They actually kind of wander around and zigzag and kind of go backwards and forwards sometime. And that's actually what the word planet means. It means wanderer. Now, the 6 planets that you can see on screen are the 6 that we can see from Earth with the naked eye. No telescopes required. These are bright enough and big enough that you can see them nearby if you're an observant looker at the night sky. However, those observant among you might notice there's a planet missing from what's on screen. The planet that's missing is the furthest planet from the Sun, and no, I'm not talking about Pluto, that's a dwarf planet now. I'm talking about Neptune. Now, Neptune is a beautiful planet, you can see that there, but it is too small and it is too dim to be seen with the naked eye. So how did we discover it? And the answer is mathematics. One of the things I think is brilliant is that Neptune is so massive that it affects the orbits of the outer planets. And so we actually were able to calculate that there was a missing object out there that we couldn't quite see with our naked eye, but it had to be there because its mass accounted for the orbits of the other planets being affected. Now, there's a little bit of a setup for you, and you could see the conflict involved. How could we know that there's a planet there without seeing it? And there's an intense amount of mathematics underneath that. And as a bonus, just to nerd out a little bit, you can deeply dive into the story of Neptune even further to explore how much mathematics there is that introduces conflict into our minds and curiosity as to how we got, for example, this photograph. I just said to you that Neptune is too small and too dim because of its distance from the sun. It's over 30 times further from the sun than Earth is for us to be able to see. So how did we get this beautiful image? And the answer is we had to send a spacecraft out there. The Voyager spacecraft took a 12-year journey to get all the way out there. It traveled 7 billion kilometers. And in order to take that photograph that you saw before, we had to get in a very particular 100-kilometer slice. Now, 100 kilometers doesn't sound like it's that difficult. It sounds very wide, actually. But to get there on the scale of this distance is actually really, really precise. How precise is it? Well, it's a little bit like hitting a hole-in-one when you're playing golf, except you're hitting the ball from Sydney and the hole is in Perth. That's how accurate and precise that it is. So you can see there's some wonderful mathematics that can be explored just by having a look at this kind of setup, this kind of hook that gets people interested and providing the conflict of how is that even possible? How could we do such a thing? So let me finish with one final setup and conflict, and then you can have a think about the resolution after this. What do you think a grassland ecosystem, the COVID-19 virus, the Nova Scotia music scene, and the Marvel Cinematic Universe, what do you think these 4 things have in common? Here's the setup, and the conflict is kind of built into the question. What could any of these things have to do with each other? What could be the common thing underneath all of them? Mathematics teachers in the room, I wonder if you can have a guess. Well, I want to unveil for you what the ecosystem of a grassland looks like. It's something like this kind of food chain. And you can see all of the different prey and predator relationships here. What does this have to do with COVID? Well, there's a web of different relationships between susceptible, infected, and recovered patients with something like COVID-19. And then, how does that relate to the Nova Scotia music scene? Well, here's a map of a variety of different musical acts that were new in the Nova Scotia scene a few years ago, and you can see how they're related to all of the different genres. And then finally, the Marvel Cinematic Universe. What's the connection here? Well, what I love is that when you think about all 4 of these things, I hope you can see the mathematical object I'm interested in is a network, a collection of interrelated objects whose relationships can be quantified and analyzed mathematically. And here it is. Here's the network underneath the Marvel Cinematic Universe. At least it was up until Avengers Endgame, where you can see all of the movies and their relationships with each other leading up to that climactic final movie. So, let me come back to the beginning. 3 acts: setup, conflict, and resolution. If you use these 3 ideas in how you connect the context that you're thinking about with the mathematics that you want to introduce to your students and you want them to encounter and become competent in, think about how you might set up and provide the information that's relevant to this situation, and then introduce a conflict, something that doesn't make sense, or a problem, a challenge that's difficult to solve. And then the resolution will be the learning of that skill for your students. All the best. I hope you find this as useful to you as it has been to me.